Question 2 says find the ordered pair of the minimum or maximum of the quadratic function given, indicate whether it's a maximum or minimum. So I'm going to go back to my reference point if I know what the shape of all quadratic graphs are going to look like. Our quadratic graph has two choices. It either looks like a smiling U or a frowning U, or a smile or U. The vertex on each of these graphs is also related back to our maximum or minimum. The vertex is the location of either our maximum or our minimum point of our graph. The other connection that we should be making is if we have a positive leading coefficient on our quadratic term, if that thing is positive, then we know that we have a smiling curve, and if I have a smiling curve, then I know I also have found a minimum point, so it's going to be a minimum. In order to find this maximum or minimum point, in this case it's a minimum, we're going to find the vertex of our graph, and we just got done doing that in question 1. Find the vertex, we run the calculation of negative b over 2a to find our axis of symmetry, and the vertex is always located out, and we'll plug it back in. So we'll run the calculation of the negative of, the value of b in this equation is a negative 10, all over 2 times a, and a is a positive 1, so it's going to be a 10 divided by 2, which is a 5. So now I know the x value, x coordinate of my ordered pair is 5. What I want to find out is what my y value is, and the way that we find our y value is by putting our input in to find out what our output is. So what's associated with an input of 5? So it's going to be a 5 squared minus 10 times 5, then plus 13. So this is 25 minus 50 plus 13, and that's a negative 25 plus 13, and that's a negative 12. So our output is a negative 12 when our input is a 5, so that means I have the ordered pair 5, negative 12. And since I know it's a smiling curve, it's going to be a minimum. So our minimum is at 5, negative 12.